Yes, all of you scan this QR code for the attendance. And meanwhile, wait for the buttons. Yes, so let's start the session. So yesterday we are discussing about the concept of virtual memory. So first of all, uh, we have to understand that virtual memory is not your real memory. That is virtual memory, which is basically used for extend the memory of the main. Okay, so, or we can extend the size of the main. Then we have discussed some of the applications where the virtual memory can be used, like for the multi-programming purpose. So what we will do, so whenever the program is executing, so we will not upload or we will not load all the instructions in our main memory. So we will upload only those instructions which is currently used. Okay, and rest of the instruction are stored in a virtual memory. So what is the benefit of that? So one of the major benefit is we can store as many as, or we can increase the multi-programming there. Okay, that means we can store a larger number of programs in our main memory. Second application, major application is, so whenever the size of the program is much larger than the original main memory. So what will happen? So it may be a problem that we cannot copy the entire program because the size of is limited and the size of the program is greater than that. So what we will do? So we will create a virtual memory and we will store the program there, and we will transmit only those programs which are currently executing. Fine. Then we have also discussed how this virtual memory concept can be implemented. There are two methods to implement this virtual memory concept. One is called your demand paging. Okay, so what is demand paging? So demand paging, the pages will be bring to the main memory only when that there will be demand. Okay, if the page is having a demand to execute, then only we will bring back. Or until the demand is not there, we will store that page in a virtual memory. Fine. So one of the now while transmitting the pages from the virtual memory to the main memory, so we are maintaining a valid and invalid bit. Suppose if the program is making requesting for a page that is not belonging to the particular program, so that means it is an invalid request. So if it is an invalid request, we have to make sure that the request should not be granted, or we have to avoid that. So for that, we are using the valid and invalid. So we have discussed in yesterday's class, we have discussed now this is an architecture for the virtual memory, how the virtual memory concept can be implemented, that we have discussed yesterday. Okay. So there are some benefits. Okay, what is the benefits of demand paging? So let us continue. Now today we will discuss about the valid and invalid bit. Then we will see how this demand paging concept can be implemented. Now in case of valid and invalid bit, okay. Now our basically the page table consists of two columns there. Okay, there will be a column for the frame, or we can say the pages, and one of the columns for the bit. Now this bit going to be stored either 0 and 1. Now as you can see in this table, now this is a particular page table. Okay, or page table. Now this page table consists of two columns here. Okay, two columns here. One is going to store your frame or pages. We can say the pages, and each of these pages are having certain bit. Okay, now you can see the bits are here 0 and 1. Now if it is 1, that means it is a valid bit. Okay, that means it is a valid bit. And if it is 0, if the bit is 0 here, that means it is invalid bit. Invalid bit means if it is an invalid bit. Now first of all, let me explain what is a valid bit. Valid bit, the request that is made by the program is a valid one. That means the pages that is requested by the program is belonging to the particular program. First thing. Second thing, if it is a valid, that means the page is also present in my memory or in my page table. Okay, it is clear. So if it is 1, that means it is a valid request, as well as the page is also present in my page table. Now if it is 0, that means if it is invalid bit, now there can be two conditions. Okay, the first condition is the request that is made by the program may not belong to it. That means That means the page that is requested, it is out of its scope. So what we have to do now, we have to make sure that the program should not be granted to the page. So that is the reason we are making it 0. That means the request that is made by the program is not valid. The second condition could be the request could be valid. That means the page that is requested by the program, okay, the page that is requested by the program is a valid one, but at the time being that is not present in my page table. Okay, so that is the true reason the bit can be 0. It is the main true reason the bit can be 0. Fine. First of all, either it can be requesting the different page, okay, or we can say it is requesting for the actual page, but it is not present page table. So this is the basic concept of using valid and invalid. Now you can see the theoretical part here. With each page table entry, we are having a invalid and invalid bit is associated with one. That one is in memory. That means it is valid and it is present in the memory. 0 this it is not in the memory. That means it is invalid bit and it is not at present. It is not belonging to the memory. Now initially the valid and invalid bit set to 0 for all entries. So initially क्या होता है? Now जब आप start करो there is no pages. Okay, if you see there is no pages, the page table is empty. Now if the page table is empty, what will happen? All the bits are 0 here. All the bits are 0 here. Now as we will bring the pages here, suppose I have bring the page 1. So what I will do, I will set this to 1. Now again I will bring as another page. Then I will also make as 1. So as we are filling this page table, so we can say as we are filling this page table, the valid and invalid bit are changes. But initially, all the entries are 0. Okay, initially all the entries that we are having are 0. And during the address translation, if the valid and invalid bit is page table is 0, so we can say the page there is a page fault. Okay. Okay. Now the very important concept we have come across here. That is a very important word that we have come across that we are going to use in the next slide. That is a page fault. So what is, you understand the page fault? Page fault means if we are requesting for the pages, okay, if we are requesting for a page and that page is not belonging to the page table, then I will say there is a page fault. That means the page that is requested is not granted, or we can say it is not present in the page table. Now, if there is a page fault will occur, if there is a page fault will occur, now what you have to do? Now, if it is a valid request, now I have to bring back that page. Now, suppose the process is requesting for the page 5. Okay. Now you can see the page 5 is not belonging to here. Okay, according to the frame number. Suppose this is to be belonging somewhere here, but it's not belonging because it is 0. If it is 0, now understand that there is a page fault. And if there is a page fault, now I have to make sure that this page should be bring back to the page table. Now, once I bring back this to the page table, now this will be set to a 1. Okay, so now we will in the next slide we will understand what are the different steps that we have to follow if there is a page fault. Now, if there is a page fault occur, okay, if there is a page fault occur, now what are the steps that we have to follow? Okay, so if you want, you can write down these points. down to the next slide. Now, this we can move down this slide because this is not second. This is my mapping technique. So we are using what? On-page technique. Okay. How we are mapping this virtual level to the program started executing. Okay. Program started executing. So I have copied all this pages. Now this is page view. Here. What is the page table? You can see. Okay. This is my frame number. Page number. You can see frame 0. Frame 0 stored which page on the page 0. Page 0 which is stored in the frame number 4 and which is the valid one. So the valid one that means is present in my main method. You can see here the frame 4, frame number 4. Okay. Frame number 4. What page is stored? Page number 0, which is nothing but your program number 8. Okay, is stored. Okay, similarly, you can see the page number 2, which is C, which is basically stored in the frame number 6, which is again the valid one. Now, frame number 6, we are looking at the frame number 6, page number 2 stored. Okay. Now, similarly, you see page number 4, which is E. Okay, now page number 4 is valid. Page number 5, which is F. Now, F is stored. Page number 9. Fine. Now, if suppose if it is interest, if some my program is for the process B, okay, for the page B. Okay, page B is that the page B is in the page 1. Okay, so I will see the page 1, the page number 1. What is the frame number? There is no frame number available because now this is an invalid bit. Invalid bit. Now there is a page fault. That means the page is not present in the main directory. What is page fault? Page fault simply defined the page is not present in the main directory. If it is not present, so in the page table, okay, I have to make sure that it is invalid. If there is a page table, if there is a page fault, now I have to bring back this page. Okay, now this page number should be bring back here. Now I will bring back here. Now suppose for the page is assigned to, I will assign to here. Now this will be. This is called page fault. If there is, if the value is valid, if value, okay, valid, that there is a page fault. Page fault means the page that is listed is not present in my. How the page fault can be detected? The page fault can be detected with the help of the page fault. Now to clearly understand how this virtual memory concept is implemented with the help of one paging and what infrastructure we are using. Infrastructure we are using is called page fault. So you can note down this diagram for the page fault. Various times we ask this question, what do you understand by the page fault? Explain with diagram. So this is the diagram. You have to draw. Okay, now you draw this diagram and explain that now this particular bit, okay, this particular frame is having page fault, or this particular frame number 3 is also having a page fault, and this particular frame number 4 is also having a page fault. Now, what is this diagram? All of you can you just move to the next slide?
sir.
Okay, so let's move on. Now this is the definition of the page model. So this page is referred in reference to the page. The first reference will be back to OS operating system will be there. Page 4. Now we go to page 4, the operating system will be at the administrator to decide whether valid reference, just not the head and flip. That is a case for step number 1. This is step number 1. Page reference page is loaded. Okay, now this is the virtual memory here. First of all, again, whatever the request we are running on, we will load that page into the page table. Now, if the page table, now this is now if it is valid. Now, if it is invalid, that means there is a page fault. Okay. If there is a page fault, okay, if there is a page fault, then we understand there is a trap. Trap in the means the page is not present in my page table. Okay. I requested when I am searching the page in the page table, what I have found the page is invalid. If it is invalid, that is a trap. Okay, if it is a trap, that is page is not present in my page table. So what the operating system will do? The operating system will again check the page in my secondary device. Okay. Step number 3. The operating system now going to check whether the page, okay, whether the page is present in my secondary memory or not. If the page is present, suppose if the page is present in the secondary memory, now that is loaded to the free place. Now we have to find in my physical memory, फिजिकल मेमोरी में जहाँ भी आपका वो फ्री फ्रेम होगा उसको आप लोग रोकना सपोज दिस इज फ्री फ्रेम click back whatever the missing page is there, whatever missing pages are found, the operating system will click back and load them. Suppose the frame number, suppose frame number after page of the folder is loaded. So once it is loaded, the work is not done. What you have to do now again, you have to update this page. Now I will update this page table. That what I will update on page T is there. In which frame? Of frame number 2. Frame number 3 is after page 3. Once it is updated, now it will be valid. To pick down is after valid action. There is no page fault. Now again I update here. Now I will update. Suppose this page number 3 is present. This is the entire process. It's the entire process because this is the 6 process that will take place every time whenever there is a page fault in my system. Fine. The 6 steps you have to remember. Okay, along with this block diagram. So what will happen? First of all, whatever the page it is requested, it is going to search in the page table. अगर आपका पेज टेबल में जो वैलिड होगा अगर वो इनवैलिड फिट है, if it is an invalid fit, that means it is a trap. Trap means there is a page fault. That means the page which is requested is not there. So what you have to do now is a job operating system क्या करेगा? Now it will search for the page in the secondary memory. Now if the page is found, that means if the page is present in secondary memory, that is loaded in my main memory. Now the problem here, now you have to find a free frame, if there is a no free frame, okay, if there is a no free frame, then you have to move the frame that is not currently used. ये बात याद रखना, ठीक है? अगर यहाँ पर free frame नहीं मिला, because there is no free frame here. So what we will do, because this is my not demand page, this is my demand page. I need this page to execute. So that means I have to upload in my main menu. I have to upload this page in my main menu. But if there is a no free frame is available, what you will do? I will swap out the page which is not currently used. Then there will be second a free frame. Then I will upload this one. Or if there is a free frame available, I will simply upload this page on this free frame. Once the memory is updated, now you have to update the page table. Once the memory is updated, what you have to do? Now you have to update the page table. Okay. How you update the page table? The page table is updated by the page number. Once you update the page table, now this invalid bit will become valid because on the page is available. Okay, a particular page is available. So once you update this page table, along with that, you have to update this virtual memory location also. This is the different steps that you have to follow. Okay, that you have to follow whenever there is a page fault. Okay, but the page fault is a page which is not demand, which is not present in my page table or in the main memory. Then you can get there is a page fault. How it is indicated? It's very simply indicated with the invalid bit. If the bit is invalid, so I can say that there is a page fault. And if there is a page fault, you have to follow this entire cycle. Okay, you have to follow this entire cycle. So note down this diagram. This is very important diagram regarding to the page fault. Okay, very important diagram regarding the page fault. If you're asking about the page fault, you have to make sure this two diagram should be drawn. Okay. Just copy down this diagram on the diagram. Steps also. What are these particular steps? Okay. Okay. So let's move on. Now the question type is here. So as I already said, so what will be happen if there is a no free frame? So whenever there is a page fault, okay, the there will be a page fault or other. So that is secondary differences and the page fault transfer. अब क्या होगा अगर आपका मेन मेमोरी में कोई भी फ्रेम फ्री नहीं है, if there is no free frame available in our data, then what we have to do now, there is a technique called page replacement. Okay, the page replacement, and we are having different page replacement algorithm. Okay, so we are having different page replacement algorithm. So whenever there is no free frame, then which frame should be chosen as a victim? Okay, which page should be replaced? Which is called page replacement. So we have to find some page in the memory, but not which is not really in use. That should be swapped out from the memory. Okay, so that there will be a vacant space for the page which is in use. We are having the different algorithms. Basically, three different algorithms we will report how this page replacement can be done. So, what are the main importance? The performance. Now we will study the parameter of performance of this algorithm. This will be result in the minimum page fault. Okay, so now if we choose whenever there is a page fault, now which pages should be chosen as a replacement, which pages should be replaced. Okay, now the performance of algorithms is based on there should be a minimum number of page fault, and some page may be brought into the memory for the several time. You have to see. Suppose पेज वन पहले बार आया है, फिर अगले बार फिर से यूज होना है, तो अगर हम पेज वन पे निकाल दें तो फिर से क्या होगा, फिर से वो पेज फॉल्ट होगा. Now you have to choose this algorithm. It is very important. You have to choose this algorithm in such a way that there is a minimum number of page fault will happen. Okay. Yeah. So as the time is going to end, so page replacement algorithm. So we will discuss about the page replacement algorithm and what is the need of this page replacement. Why do we use this? What are the need of this page replacement? The next class we will discuss this one. Okay. So from time being, those who are not able to attend it, and this you are good for that.